Hi, welcome to this video. In today's video, I'm going to do this problem. This is International Mathematical Olympiad of 1959, problem number 1. The question: prove this fraction 21n plus 4 divided by 14n plus 3 is irreducible, okay, for all natural number. So now I'm going to assume this fraction is irreducible, okay, by assumption. Then at the end we find contradiction, okay. So by proof of absurd, so now assume 14n plus 3 over 21n plus 4 is a reducible fraction. For all natural number, okay. So now, since this fraction is a reducible fraction for all natural number, where p is divisible of numerator and denominator, okay. So 21 and plus 4 congruent to the 0. I'm going to multiply both sides by 2. I will have 42n plus 8 congruent to the 0. P congruent to the 0 modulo p, okay. So for the numerator we have 14n plus 3 congruent 0 by arithmetic rule, okay. So this one going to multiply this one by 3. I will have the same thing. This one 42n plus 9 congruent to the 0 modulo p, okay. So I'm going to, let's call it equation number 1. Let's call it equation number 1. This one equation number 2. I'm going to subtract equation number 1 from number 2, okay. So that's mean 2 minus 1 implies, so 42 and plus 9 minus 42 and plus 8 is giving you the difference congruent to the 0 modulo p, okay. So equivalent, 42 and will be cancelled out because we have one is positive, the other one is negative, so you will have 1 congruent to the 0 modulo p. This is contradiction. 1 congruent to the 0 with modulo p. That's mean, okay, that's mean by absurd, this is contradiction. So now I have done with this method. I'm moving on to the second method, okay. In second method, I'm going to write this fraction as follows: 21n plus 4 over 14n plus 3. It can be written on this form: 14n plus 3 plus 7n plus 1 over 14n plus 3. I'm going to divide numerator and denominator by 14n plus 3, okay. I will have 1 plus 7n plus 1 over 14n plus 3, okay. That means 7n plus 1 and 14n plus 3 should be comprime numbers for all natural number for this fraction to be reducible, okay. I'm going to write this one on the other form, okay, to make it more clear, okay. So 7n plus 1 over 14n plus 3 can be written on this form. 7n plus 1, in the denominator I will have this one 2 times 7n plus 1 plus 1, okay. So this one I'm just writing the denominator on this form to show up the numerator, okay, on both, to show up numerator and denominator, okay. So I have this one written on this form. So since denominator since denominator is different from multiple of numerator, okay, by 1. The difference between the multiple of the numerator and denominator is number 1, okay. So hence, so both both numerator 7n plus 1 and denominator which is 27n plus 1 must be prime numbers for all natural number, okay. Thus 1 n plus 4 over 14n plus 3 is irreducible. I have done with this one. This is a good place where I can stop. Thank you for watching. I will see you in next video. Bye.